So once again, today we're looking at a technique called trig substitution. It's yet another method to solve integrals. And the interesting thing is, you might say, well, are we going to solve more trigonometric integrals? Haven't we already done that in the last section? And the answer is no. A given question in this section might be something like this. A given question might be something like the integral of, let's say, the square root of x squared plus 1. This might be a typical example in this section. So the questions we're looking at today don't necessarily have a trigonometric function in them as it is given to us. Like this example I put on the board, square root of x squared plus 1 doesn't have any trigonometric functions. And the interesting thing is, we're going to bring in the trig functions to solve this integral and to simplify it, and then we're going to get rid of the trig integral. So we're going to use trig functions to help us solve integrals. But again, we're going to bring them in, and then we're going to get rid of them. So the given question has only x's in it, and our final answer will have only x's in it. Now, here are the substitutions that we're going to be using in this chapter, in this section. Basically, we'll have three possible substitutions. If you have, like in the first case, if you have the square root of a squared plus x squared, we're going to let x be a tangent theta. If you have the square root of a squared minus x squared, we're going to let x be a sine theta. And finally, if you have the square root of x squared minus a squared, we're going to let x be a secant theta. Now, these are important substitutions, and we need to remember them. Now, what is the difference between the second and the third? How are we going to know when we're using sine and secant? Because tangent is easy, right? When you have a sum in the middle, the sum of two squares, you're going to use the tangent substitution, right? But when there's a minus in the middle, how will you know whether you're using a sine theta or a secant theta? Any suggestions? Yes?
Well, the x and the a are reversed.
Right. So if the variable square comes first, we're going to use the a secant. If the number square comes first, we're going to use the a sine theta. Now, let me give you a little bit of background. Where did these things come from? They didn't fall from the sky. There is a reason why we're using these substitutions, and let me try to explain to you exactly why they are helpful in these problems. So let's say the case of a tangent theta, okay? What would happen if you plug it back into that square root? What would that square root become? Instead of x plugging in a tangent theta, you would have a squared plus, what could I write for x squared if x is a tangent theta? What is the square of that? Right, in other words, if you simplify that, that's going to be a squared tangent squared theta, right? Okay. If you simplify it a little bit, take out an a squared, now you're left with 1 plus tangent squared. And do we have an identity for 1 plus tangent squared? Secant squared, right? So that's exactly why we're using tangent theta when you have sum of two squares, because there is an identity that says 1 plus tangent squared equals secant squared. And why is that helpful in this case? Why writing this again as a squared times secant squared? Why is that helpful? Because now you can take it out of the square root sign as what? A times secant theta. Normally it's the absolute value of that, but we're assuming things are positive, so it's just a times secant theta. So you see, a difficult square root sign can be simplified by bringing in the trig functions and then using some of these famous trig identities like 1 plus tangent squared is secant squared. Now try one of the other ones. Say let's try the third one down the list. The third one. Why do you think a secant theta is going to be helpful in solving that last type of a square root problem? So I'm going to erase this and just do a demonstration about that one. So if x is a secant theta, what would the square root become? It would be the square root of, okay, x squared. What is x squared in this case? A squared secant squared minus a squared. Factor out the a squared. By the way, let me ask you a question, because I see this all the time. Students make a mistake. This is what they do. They take this out. The first part is a secant theta, and they take the second part out as a. So they put like a secant theta minus a. Can we really do that? When you have a minus in the middle in a square root sign, can you take individual pieces outside of the square root sign? No, it may be tempting to do so, but we cannot do it, right? If there was a multiplication in the middle, right here, then you can take things out of the square root sign, right? But with a subtraction or addition, we cannot take things out of the square root sign. But we can do the following. Take out the a squared, so now you have secant squared minus 1. And what do we know about that one? What is secant squared minus 1? Tangent squared. Now can we take things out of here? This will come out as a times tan theta, right? A times tangent theta. So you see why they picked secant theta in that case and not another substitution, because secant theta is the one that makes this possible. Secant squared minus 1 is another perfect square trig function. So if you ever pick the wrong one, you may come to a point where you don't end up with a nice identity. Then go back and pick the other one. Then so again, sum of two squares, we always use the tangent substitution. Difference of squares, either sine or secant, depending on whether the variable or the constant comes first. Now let's do an example to see what we mean by these substitutions, how we can really use them to make to solve integrals. And here's our first example. Get rid of this demo. Okay, so here's our example number 1. Let's solve the integral of dx divided by x squared times the square root of x squared minus 25. Okay, trig substitution is a complicated method. Before you decide to use this, make sure that you rule out all other possibilities. For example, could we have solved this question using u substitution? Let's think about that for a moment. If we let u be x squared minus 25, well, there is no x dx on the top, right? That's not going to work out. Could we have used integration by parts? Nothing obvious here. It's not an obvious, separation as u and dv. But this is not a trigonometric integral, so let's try this new method. And how do I know that I could try this new method? Because I have a square root on the bottom and difference of two squares within it, right? When you have sum of squares or difference of squares, think about this new technique called trig substitution. In this case, let's let x be equal to what? To solve this, let x be equal to. Now, which of the top 3 does this look like? First, second, or the third? The third, right? X squared minus a squared. And what is our a? A is 5. So I'm going to let x be equal to 5 times secant theta. Would everybody agree? Okay, let x be 5 secant theta, because I'm going with this, the third one from above, and my a is 5. Okay, at the moment, okay, so we're saying, so what? We picked this substitution. It doesn't simplify the integral. Not yet, but let's do 2 things. Number 1, immediately find dx. Dx is equal to 5 times secant theta times tangent theta d theta. So we're going to go back to our original integral and rewrite everything now in terms of theta. So instead of dx, I'm going to place 5 secant theta tangent theta d theta and divide everything on the bottom by, okay, we need 2 expressions. First of all, for x squared, what should I be writing? Since x is 5 secant theta, exactly 25 secant squared theta for x squared. Okay, and how about under that square root sign? We have x squared minus 25. X squared is first squared 25 secant squared theta minus 25. So what I want to do is I want to simplify what is inside the square root there. I could take out a 25, right? That will leave me with secant squared theta minus 1 inside the square root sign. That's how I can simplify it. And what is secant squared minus 1? One of the important identities. Tangent square, right? Secant squared minus 1 is tangent square. So I can replace that with tangent square in the next step. So at the moment, I'm just going to write everything else as they are. 5 secant theta, tangent theta, d theta. On the bottom, we already had 25 secant square theta. And now under the square root, I'm going to write 25 times tangent square theta. Okay, so once again, let's try to simplify this a bit. How am I taking the 25 tangent square out of the square root sign? 5 tangent theta, right? So write everything else as they are. In the next step, we're going to be doing a lot of simplifications. So let's cancel away things that can be canceled. The 5's are gone. The tangent thetas are gone. So what I'm left with is 1 over 25 times the integral of secant over secant square. And even that can be simplified, right? How can I write that one? Precisely, 1 over secant theta d theta. So we get to this point where we end up with a simple looking trigonometric integral. Do you see why this section follows the last section? Because once you've done all the simplifications, you will always end up with a trigonometric integral in this last step. Okay, so now we're going to use things we learned from the last section. So 1 over secant theta doesn't look like anything we've seen before, but can we simplify that? What is 1 over secant theta?
1 over cosine.
I heard one suggestion. I heard it's cosine. Would everybody agree with that? Because what is secant in the first place? Secant is 1 over cosine, right? We should obviously know the 6 trig functions very, very well. The six trigonometric functions, sine, cosine, tangent, secant, cosecant, and cotangent. So secant theta is 1 over cosine. So now what you have is 1 over cosine, so that will give you cosine theta d theta. So Joshua was right. The answer is cosine theta. And what is the integral of cosine theta?
Negative sine.
Not the derivative, but the integral. The integral of cosine is, would everybody agree, positive sign? Right? We should know that by now, right? Plus c. The only problem with this answer is it has a theta in it, whereas the original question only had x's. So as a last step in every one of these questions, we're going to try to get rid of the theta and bring in the original variable x. And to do that, we're going to need a triangle. And here's how we're going to do that. We draw a triangle where, from this original substitution, if x is 5 secant theta, that means x over 5 is equal to secant theta. Would everybody agree with that statement? If x is 5 secant theta, then x over 5 is secant theta. Any questions about that one? Okay. Now, tell me from trigonometry, what is the ratio for secant? Like opposite over hypotenuse or hypotenuse over something? What was secant? Secant is?
Cosine. I know that cosine would be hypotenuse over adjacent.
Because cosine is adjacent over hypotenuse, right? So secant is the opposite, hypotenuse over adjacent. So what we want then is we want hypotenuse over adjacent to be x over 5 in this triangle. So hypotenuse is x, adjacent is 5. And how about the third side? What will that be? And let me try to hear from other students, if I may. Yes, I think Garrett, you were saying something? Because we're going to use the Pythagorean theorem, right? If the hypotenuse is x, one of the legs is 5, what will be the length of the other side? The square root of x squared minus 25, right? The longer side, the hypotenuse squared minus the leg squared, x squared minus 25. Okay, so here's what we need right now. From that triangle, the only thing we need is we need to know what sine theta is. What is sine theta in that triangle? Please let me hear from other students. What is sine theta in that triangle? I'll bring it back up right there. Okay, so if you have an answer, would you please let me know for sine theta, what would you say from that triangle? Yes, Courtney. The square root of x squared minus 25 divided by x, basically opposite over hypotenuse, right? That is sine theta. And don't forget the plus c. So here we have the answer to the original problem that we started with. Remember, the original question was a problem in terms of x's. There was no trig function in there. We brought in the trig functions. We simplified our expressions. At the end, we got rid of the trig function. So once again, the answer is an algebraic expression with no trigonometric functions at all. If I wanted to check this answer, would there be a way to do so? How could one go about checking this answer? You would have to find the derivative of this, right? And that should be equal to the original question that we started with. But that would require using the quotient rule, so you can check it, but you have to be very careful. And you're going to use a chain rule when you differentiate the top. But it is possible to check it by differentiating it and using the quotient rule. So to solve this question, once again, first let's think about, can we apply U substitution for this question? What would you need to have in order for this to work with U substitution? An x on the top, right? We don't have that x. Second thing I would ask you is there like a package formula that we could use for this? If so, there's no reason to apply this long technique, right? Is there a package formula? Like an arctangent or an arcsine, something like that? Well, if it had been just this, dx over 9 plus x squared, there is a package formula, right? And what is that formula? The arctangent function, so 1/3 arctangent x over 3, right? Important formula, we should know that one. What if it was something like this, dx over the square root of 9 minus x squared? That's another important formula that we should know. That's arcsine, right? It's arcsine of x over 3, right? But now you have a square root, but not difference, but a sum in the middle. So it doesn't apply to this first expression here, nor does it apply to the second expression we wrote. So this is something different. There is no simple formula for it. So we're going to do this one using trig substitution. Now, how do I know, once again, that trig substitution would work well here? What is the key term that you see here that you know that trig substitution will make this work? Yes, Gracie? Exactly. You have a square root expression within which you have sum of two squares. That is a sign that trig substitution will work here. So let's try it with trig substitution. What would be a good choice? Let x be equal to what? 3 tangent theta. Let me stop for a moment, see if everybody agrees with that substitution. This is the first one of the 3 that I wrote earlier on the board, right? When you have sum of two squares, then we're going to go with a tangent theta. When you have difference of two squares, you either use the a secant theta or the a sine theta, depending on the problem. Okay, what is the next thing that I should do here? Find dx, exactly. It's a step a lot of students tend to forget, so let's just make sure we do it right away. Dx is equal to 3, and the tangent is secant square theta d theta. So we come back to our question up here. So that integral now becomes the integral of, okay, instead of dx, I'm going to write 3 secant square theta d theta. And in the denominator, I will write the square root of 9 plus. Instead of x squared, what shall I write? I need to square the x, right? If your x is 3 tangent theta, x squared will be 9 tangent square. Okay, let's simplify this. Especially, let's simplify what is under the square root. That square root is equal to the square root of 9 times 1 plus tangent square theta. And what do we know about 1 plus tangent square theta? What is 1 plus tangent square? Secant square, right? And how will that get out of the square root sign then? What is the square root of 9 times secant square theta? Because there's a product in the middle, you can take each one out one at a time, right? So the 9 comes out as a 3, and secant square comes out as a secant. So in the next step, I'm keeping the top exactly as it was. 3 secant square theta d theta. And on the bottom, since I have simplified that square root down all the way down to being 3 secant theta, so I will only write down 3 secant theta down there. So calling everything the original question I. So now I have the integral equals. After you've done all the simplifications above, let's write down your final answer, which should be what? The 3's are canceled, right? Secant square over secant is secant theta. And this was one of the questions in your group activity last time, right, in your 8.3 group activity. And it was also one of the integrals I gave you on the first day on that integrals handout sheet that listed all the integrals you should know and those that I would be giving to you. This one I didn't ask you to memorize, the integral of secant theta. I said this one I would provide to you if you need to know the answer. Does anybody remember by any chance? Yes, Garrett? Exactly. ln of secant theta plus tangent theta. This one I would give you on the test if it came up. Plus c. Technically, we're done. We've integrated everything. What's wrong with this answer? What is it that we need to do one step further? Put back in the x variable, in the original variable, because the given question did not have a theta, so we don't want to leave it in terms of theta. In order to get rid of the theta, I need a triangle. And let me create it over here. Okay, so call one angle here theta. And always go back to your original substitution. We said let x be equal to 3 tangent theta, right? From there, I know that tangent theta in this triangle should be what? Since x is equal to 3 tangent theta, then x over 3 is tangent theta. And we know that tangent is opposite over adjacent, right? So x on this side and 3 on the bottom. And what can I write for the hypotenuse of this triangle? Exactly, the square root of x squared plus 9. So now we come back to finish the question. ln of okay, from this triangle, I need to know what secant theta is. Secant, once again, is hypotenuse over what? Adjacent, right? Because secant is 1 over cosine theta, is hypotenuse over adjacent. Hypotenuse here is the square root of x squared plus 9 over the adjacent, which is 3. And how about tangent theta? X over 3. I don't even need a triangle for that one, right? I could even look at this equality down here, or look at the triangle. Either way you do it, you're going to get tangent theta equals opposite over adjacent, which is x over 3 plus c. This is fine. You can leave your answer exactly like this, but I want to show you another way that you might see your textbook leave the answer. Your textbook may have the following. ln of the square root of x squared plus 9 plus x plus c. Which is weird, right? Where did that 1/3 go from the first piece and the second piece? Would anyone have any clue about, hypothesizing where that 3 could have gone? It's not obvious. When you take differential equations, you're going to see this kind of simplification all the time. And what they're doing is they're combining the constants. And here's how. Here's how they do it. So I'm just going to say here or, because you don't have to simplify it that much. But if you were checking your answer with the book's answer, I want you to know that these are equivalent. And here's the reason. This one right here could be rewritten as follows. This one could be written as ln of the square root of x squared plus 9 plus x all over 3. What have I done there? Combine them as a single fraction, right? Now, what do you know about ln a over b? How can you write it as a difference of two logarithms? This is ln of the top, right? Minus ln of the bottom, which is ln of 3. And remember, at the end of everything, there was a plus c, right? So basically, what they're doing is they're saying, well, this is just a constant, and there's another constant, and we might as well put them all together and call it another constant, say capital C or C prime or K. So basically, you can leave the answer like this plus another constant, and that would be equivalent to the answer we got originally. But at the moment, I'm just going to circle the first answer that we got. And the second one, I was just showing you that, the textbook sometimes may leave the answers in that format. Just be aware. Okay. Any questions